Please see the link in the description to download a worksheet for this video. In math, we use the words divide and division in a slightly different way than we do in everyday talking. This can cause confusion when we're learning about division and fractions. From a math perspective, which food or foods were divided? Before we answer that question, we need to learn about division. In this video, we'll discuss basic concepts about division in math. We'll cover the first requirement for division, division symbols and number names, the difference between cuts and parts. The second requirement for division, and how division is related to multiplication. We'll start with the first requirement for division. There are two key requirements to the math definition of division. The first one is that the parts or groups made from the original whole or group must be equal size to each other. Once this baker has finished slicing the bread, the first division requirement is met because each slice is equal size to the other slices. In contrast, the cake has been cut into one small and one large part, so we would not say that the cake has been divided. Likewise, if we cut the plastic stick into two parts of unequal size, this isn't division. But if we cut the whole into equal parts, then that meets the first requirement for division. If we have a collection of whole objects, then when we divide them, we put the same number of wholes in each group. In this case, each group has 3 objects. We can also divide one stick into 5 equal parts, in which case now each group has 3 1/5 of a stick. This is a mixed fraction. Next, we'll discuss division symbols and number names. Which symbol or symbols means the division operation? All of these symbols represent the division operation. All of them say 6 divided by 3. The number that is divided is called the dividend. The number that does the dividing is called the divisor, and the number that is the answer is called the quotient. In middle school and beyond, we rarely use the division symbol or the long division sign. Instead, we almost always use the horizontal bar to mean division. For example, let's say we're given this problem. This is Billy and Susie. They're walking at a speed of 3 miles per hour. They want to know how long it will take them to walk 6 miles. Using a division symbol, we could say that the time they'll need to complete their walk is equal to their travel distance, which is 6 miles, divided by their travel speed, which is 3 miles per hour. So the travel time is 6 divided by 3, which equals 2 hours. Rather than use the division symbol, this is how we typically write an equation with a division operation. We would pronounce it like this. The travel time is equal to the travel distance divided by the travel speed. Next, we'll discuss the difference between cuts and parts. In everyday life, we think of the words cut and divide as meaning the same thing. For example, we might say this man is dividing this apple in half, then he divides each of those halves. So we might say he divided the apple 3 times. But in math, we write down the number of parts or groups that result from division. We don't write down the number of the cuts. So we would say the apple is divided into 4 parts. We don't write down the number 3 anywhere. For example, this baker is cutting some dough into 3 equal parts. He's doing that by making 2 cuts. But we don't write down the number 2 anywhere. Since there are 3 parts after he makes the cuts, we only write down the number 3. In everyday talking, we would say that before the baker cut the dough, it has not yet been divided, so we might think that the number of divisions is 0. But in math, we could say that it has been divided into 1 part, even though it was never even cut. The main thing to know is that we never put a 0 in the denominator or use it as a divisor. In contrast, we can have 0 in the numerator. That happens after all the parts disappear. Next, let's discuss the second requirement for division. In everyday talking, we would say that to braid someone's hair, we start by taking a handful of hair, then divide it into 3 equal size strands. Then, we alternate crossing the left and right strands over the center strand. Since the strands are equal size, this meets the first requirement for division. But it fails on the second requirement, so this is not division according to the math definition. Likewise, in everyday language, we might say that this man has divided his sandwich in half. Since the 2 parts of the sandwich are equal size, this meets the first requirement for division. But it fails on the second requirement, so this is not division. To find out what the second requirement for division in math is, let's solve a division problem. Both of these division expressions say that we have 1 whole and are dividing it by 4. We commonly call this amount 1/4. We can use a calculator to find that the quotient is 0.25. Now, let's say the whole we are referring to is this apple, that we're cutting into 4 pieces. Which plate represents these division expressions? Only the plate on the right contains a quarter of an apple, which we can express as 0.25. This observation tells us the second requirement for division in math. All the parts or groups made during the division must be discarded, except for just one of those parts or groups. For example, this whole block of ice has been cut into 2 parts, but the amount of ice present only equals 1 divided by 2, which we commonly call 1/2 when just one part remains. In addition to wholes that we cut into parts, this second requirement for division in math also applies to collections that we break into smaller groups. Earlier, we divided a collection of 15 sticks into 5 smaller groups. The answer to 15 divided by 5 is 3. The number 3 refers to how many sticks are in one group. We discard the other groups and do not count those sticks. Our final topic is to talk about how division is related to multiplication. When we multiply these blocks by 3, we first consider these 2 blocks to form one group. Then we make a total of 3 groups. Next, we count up the number of blocks and find our 6. With division, we divide the 6 blocks into 3 equal-sized groups. Then we keep just one group and discard the other groups. Finally, we count up how many blocks are in that group, and we find our 2. Since we started with 2 and ended with 2, that means multiplication and division are opposite operations. Sometimes we call them inverse operations. They work in exactly the opposite way, so they can undo each other. Now we're ready to return to our opening question. The apple pie has been divided according to the math definition because it has met both of the math requirements. First, it was cut into 9 equal-sized parts. Second, only one part remains. This is division. We can express this with the horizontal bar. And we can express this using the division symbol, in which case we get a decimal answer of 0.1 repeating. Here's a summary of this topic plus some additional information. Please pause the video if you wish to read this. Thanks for your attention.